Hey engineers, this is Mr. Hernandez, and in this video we're going to go over our most recent lessons in Tinkercad and 3D modeling. So as I'm recording this, NASA has just officially announced that they safely landed the Perseverance rover on Mars. So that's got me thinking about space a little bit, and so that's going to inform the topic this week. So let's go ahead and take a look at what we're doing. We are going to be, as I said, working with space and space themes and making a scale model. Let's start with a fun fact. So you can actually fit every other planet in the solar system in the space between Earth and the moon. That includes the huge planets like Jupiter and Saturn, or the moon actually orbits so far away from Earth that you can stuff all of those planets in there. That'd be a terrible idea, so all the planets would crash into each other. But it's one thing that shows you just the mind-blowingly large numbers that are involved when we talk about space. So we are going to be making a scale model. So a scale model is a copy or a reproduction of something that includes all of the important features and importantly proportions, but you change the size. When you're making a scale model, it's important to define the scale. The scale is the ratio between the original size and how big the model is. So for example here, we have a full-sized Mustang. This one's actually a famous Mustang from a movie. It's named Eleanor. And so because it's a famous example, there are toys and scale models made of it, like this one over here. So this is a 1/24th scale model. That means that anything on this car, the real life car, that's found on this car, is going to be 1/24th the size. Now, engineers use scale models for a lot of reasons. A lot of the times it's to save on money or to make things easier to test. For example, if you're testing out a new type of airplane, you don't want to build like a full-size passenger plane just to test out, what's going to happen if we put winglets on the ends of the wings. Instead, you make a scale model. You have to be really careful to make sure it's going to behave the same way, but that lets you test things out without having it be so huge. So we're going to be using a scale model to model the solar system in Tinkercad. First thing we have to figure out is what our scale is going to be. It's kind of a problem because, like I said at the beginning, space is a really big space. Like it's really, really incredibly large, the numbers that we're dealing with. Even if we're just talking about our solar system. Um, it in fact gets to the point where it actually gets a little bit silly to think about the numbers involved. Like you might think that talking about distances is crazy if you say something is millions of miles away or billions. But no, in reality, when we're talking about space, things can be trillions of miles away. Um, Now, this is an image of the pillars of creation, a nebula found in our solar system, and it's actually a nursery for entire stars. So our entire solar system would fit into one of these little nubs right there. And even within our solar system, we're talking about things that are hundreds of thousands of miles apart, even millions of miles apart. So, all right, let's try and shrink that down here as we figure out our scale factor. So there's a few things that go into this. Um, when we're shrinking things down from the solar system to Tinkercad, the most important thing that we have to be concerned with is that Tinkercad will only let us make something of a certain size. It does have a maximum size limit, and Tinkercad mostly works in millimeters. That's actually going to come in and help us. Now, in order to get the solar system and those planets to fit in Tinkercad, we need a scale factor ratio of 1 to 640 million. So remember, that car we looked at was a 1 to 24 ratio. This is going to be a 1 to 640 million ratio. Now, that's going to be a little bit difficult because those numbers are going to get super wonky as we make that change. But luckily, with the metric system, because everything's just multiplying and dividing by 10, there is one part of that that we can actually ignore a little bit. You see, 1 kilometer is actually a million times bigger than a millimeter. It goes 10, 100, 1,000, 10,000, 100,000, a million times bigger. So if we just ignore that, if we just treat kilometers like they're millimeters, we get a 1 million times scale factor kind of for free. So it's happening in the background with the units, and that means that the ratio that we're going to actually use is 1 to 640. Let me show you guys what we're going to do for each planet, and then we'll go ahead and take a look at the specifics here. So for each planet, except for Earth, you're going to use whatever resources you need to, whether that's using Google to get to a primary source, looking it up on Wikipedia, going to a NASA website. This is all pretty easy information to find, so any trustworthy source that you can find should be viable. And we're going to try and find out what the distance that planet is from the sun in kilometers. Then we're going to find out its diameter in kilometers. Make sure you're finding the diameter, because some websites are going to report this as the radius, and the radius is only going to be half of that distance. So we need it to be the diameter. Then, now that you have your diameter, we're going to divide that number by 640. That's the scale size. So this is the process that we're going to use as you're filling in your 3D modeling report. So in this one, you can see all of the spaces that you can fill in here. So there's the distance from the sun, the actual size, the scale size, and finally the color. And I want you guys, there's a space here for a picture of each. That's going to be a screenshot of your model. So let's, before we go in any further, make sure that we're all working on the same page here. So up here, there is a link to the template. So you can click on this link, and this is actually why you don't need to make a model of the Earth. I've already modeled the Earth and the moon for you, and they are already spaced out the correct distance apart. So all you need to do is click on that link and then click copy and tinker, and this is the space you're going to be working in. So let's move on to Mercury. So Mercury, distance from sun. Okay, so here, this looks like it's a pretty good source. So Mercury is 61 million kilometers away from the sun. That checks out because Mercury is the closest planet to the sun. So it makes sense that it's smaller, or it's less than the distance from the Earth. Okay, and now let's look up the actual size. And remember, we want the diameter of Mercury in kilometers. Now, like I said, this is pretty basic information, so Google is pretty good at accurately putting that into these little fact bubbles up here. So Mercury is 4,879.4 kilometers in diameter. And now let's go ahead and calculate that scale size. So 4,879.4 divided by 640. So that means that our scale size is 7.624 millimeters. And last, the color of Mercury. We've got an image right here, and Mercury looks very gray. So I'm going to put that down there. Now, we need to actually make a model of Mercury. So let's jump into Tinkercad, drag out a sphere. I'm going to make it gray. And now we need to set the size. Now I've got a couple of tricks for you here. So the best thing that you can do is click on one of these corners. See how it's highlighted in red? Well, I'm going to press and hold the Shift key on my keyboard and click on that corner. See how when I drag it, it stays a sphere? This is what happens if I don't click Shift. I can make it into like an oval or an egg shape. So in order to keep it spherical, click Shift first and then click on it. But the problem is, clicking and dragging is not very accurate. And see how the numbers are kind of just going in steps of 1? I don't want to go in steps of 1. I want to set it to exactly 7.624 millimeters. So when you click on this corner and click Shift, that'll enable you to type in to these windows here. And whatever number you put in there will also get copied to the other directions. So even though you're not clicking and dragging, because you clicked Shift at the beginning, it will still change sizes proportionately. So once you have your model of Mercury created, what I want to do here is align it to the other models here. So I want to line it up that way. I want to raise it up to be in line with the Earth and with the Moon. And then I'm going to move this all the way to the left, because remember, we're going to fit in a model of every planet here. You can definitely adjust these so that they're lined up as closely as you want them. And here, this is the screenshot that I'm looking for. So for Mercury, I would definitely take a screenshot of Mercury compared to the Earth. You can add a label too if you want to, but that part is optional. And this image is really helpful because it shows the ratio between the Earth and Mercury. See, the Earth was 12,000 kilometers in diameter, so it makes sense that it looks much bigger than Mercury in this image. And with all of your subsequent screenshots, try and get the planet and the planet next to it as well. So you're going to do this for each of the planets in the solar system. So again, Earth is there for you already, the Moon is there for you already, but you're also going to do Mercury, Venus, Mars, Jupiter, Saturn, Uranus, and Neptune. Sorry, no Pluto. Lastly, we also have the Sun. Now, obviously, the distance from the Sun is 0, but I also want you to look up its actual size and figure out what scale it would be in Tinkercad, and also what color it is. Taking the screenshot of it is optional, because the Sun is actually, just a little spoiler here, it's so large that it's difficult to make it in Tinkercad. So that's why it's optional. I do encourage you guys to try it out, but make sure that you get the screenshots of all of the other models first. Now, regardless of whether you made the Sun or not, the very last step here is to zoom way out and take a screenshot of the entire solar system. So just zoom way out, and you should be able to see, if you built them to the right scale, that you can fit every single planet in the space between Earth and the Moon right here. By the way, I already did this calculation, but on this scale, the Earth and the Moon are 633 millimeters apart. So on your own time, you can look up what that actual distance is. All right, engineers, I hope you guys have fun with this assignment. This is definitely the kind of model that I would love to 3D print. So before we go back to campus, I will probably be trying to complete this at some point. All right, engineers, so that is the whole assignment. I hope you guys have fun with this one. You can get creative a little bit when you're making the planets. For example, if you want to label them or you want to include Saturn's rings, I'd say go for it. And as always, remember that you can send me an email and come to office hours if you need any help on these assignments. Good luck, everybody.